Lesson 4.7, page 262, and this lesson is finishing chapter 4. It's entitled Graphing Linear Functions. You have seen linear functions written in the form y equals mx plus b. That's called slope-intercept form. Instead of using the variable y, however, we can write this equation in function notation. Function notation looks like the following. You notice, instead of having a y, they changed the symbol y to f of x. Now, what does that mean? Why would they do that? Well, first of all, they use f of x. That's entitled function notation. It's basically just a different language. So when you look at y equals mx plus b, and then you have, let me write underneath that, f of x equals mx plus b, you're talking the same thing. It's just that in the top, this is just an equation where when I write it this way, this is called function notation. The symbol f of x is another name for y, and you read it as f of x. Be careful. That does not mean f times x. This is not two different variables. This is not an f times an x. This symbol is function notation. It means f of x. It means function notation. One thing we're going to have to do in the homework, you will need to find the value of a function. A pretty simple process. So here would be an example. What is the value of the function f of x equals 3x minus 15 when x is negative 3? So I haven't done this in a while. Let me draw my box. My box is going to take x. It's going to multiply it by 3 and subtract 15. And this is saying to take negative 3, put it in the box. So that's obviously telling you to take the 3 times the negative 3, which is negative 9, minus the 15, and that would equal negative 24. So the output of this, so f of x would have to equal negative 24, and that would be choice A. All right? You also would have to be able to find the given the value of the function, you should be able to find x. So look at this example. For the function f of x equals 2x minus 10, let me draw a picture of that using the box. Find the value of x. So I'm trying to find x so that f of x equals 6. In other words, we're trying to figure out what number would I plug in for x to make this work out to 6. So that's easy to figure out. Just write 2x minus 10 and make it equal to 6 and solve it. So add 10, which would give me 2x equals 16, and then I can divide by 2, and that would give me x is 8. And you can see that's what the book is saying you should get. So these two scenarios, maybe I'll just take a highlighter, these two scenarios will come up in your homework. They will ask you to find the value of a function, which is they'll give you x, and you'll have to plug it in and find what f of x is. But you'll also see in the homework problems where they're going to tell you the value of the function, and they want you to figure out x like they have here. Domain and range, I've been talking about that all chapter. Now this sounds technical, but it's the same thing I've been telling you all chapter. The domain of a function consists of the values of x for which the function is defined. And you might be like, well, what the heck is that saying? What's that supposed to mean? And it's like I've been telling you all chapter. The domain is the values that you can plug in for x. That's what domain is. It's the ones I can plug in. The range consists of the values of f of x, where x is in the domain of f, and the graph of the function f is the set of all points x, comma, f of x. So this means that the range is all the possible outputs. That's what that verbiage is telling you. So when I plug these values in for x, I'm going to get a certain group of outputs. That's what the range is. And then this little part here is just saying that these can be graphed using ordered pairs like this, except instead of using the variable y, they just replaced f of x. So I'd have x comma f of x instead of x comma y, but it's the same stuff. We can graph ordered pairs. All right? You can see that here, like in this sample word problem, the gray wolf population is in central Idaho, was monitored over several years for a project aimed at boosting the number of wolves. The number of wolves can be modeled by this function, and I'll just underline that. Where x is the number of years since 1995. Graph the function, identify the domain of range. Well, before we graph, we got to figure out what values can I plug in for x. Now remember, x is the number of years since 1995. So if I plug in 0 like they do here, that means 1995. If I plug in 1, that would be 1996. If I plug in 2, that'd be 97. I can't plug in negatives because that would be backward in time, but I could plug in any positives. So that's why the domain, you can see, is x greater than equals 0. Okay, so now look at the table. I plug in 0 and I got an output of 7. And I plug in 1 and I get an output of 44. And if I plug in 2, I get an output of 81. Do you notice how the y values, which right now is f of x, do you notice how these keep growing starting at 7? So let's write that. These keep growing starting at 7. Well, that's what this says. F of x is equal to or greater than 7. That's my range. And then I can graph it. So really, other than the symbolism being different, you've done these problems all chapter. It's just instead of using y, we're going to use the symbolism f of x. That's function notation. Let's talk about a family of functions. This is another thing you'll definitely have to understand and be able to apply in your homework. A family of functions is a group of functions with similar characteristics. For example, functions that have the form y equals mx plus b, do you notice that's slope-intercept form? Functions in this family would be linear functions. These are all straight line graphs, so the functions in this form would be the family of functions that are straight line graphs. That's what this is saying. Let's talk about what the parent function of this family is. The parent function is the most basic function in that group. Here is the most basic linear function we can write, f of x equals x. Let's analyze this a little bit more. I'm going to write it over here. When you write f of x equals x, let's think about that for a minute. That means the slope, let me write it in here in a different color, the slope would have to be 1, and you notice that I do not see a b value here, which means my y-intercept would have to be 0. So this is the parent function. It has a slope of 1 and a y-intercept of 0. The parent function of linear functions always has a slope of 1 and a y-intercept of 0. So what they're going to ask you to do in the homework then is they're going to say, and we're going to do I think 1 or 2 of these. Let's go to page number right now. Open your book, or I should say go to page number 266. Let me write that down, page 266. And let's do problem number 23 together. And the directions for problem 23 say the following. Graph the function, that's 1. So let me write these down because there's more than one thing to do in the problem. So we're going to graph the function. Then it says compare this graph with the graph of f of x equals x, which is the parent function. Compare means we're going to write sentences that explain or contrast the difference between what I graphed and the parent function. So let's graph the function. So for 23, let me write the problem down. It says f of x equals x plus 5. I'm sorry, g of x. G of x equals x plus 5. Okay? Let's graph that. Now, first of all, do you notice this is in slope-intercept form? Okay, it's very important that we can diagnose slope-intercept form. This is y equals mx plus b form. Are you seeing that the slope is 1? And are you recognizing that the y-intercept is 5? We should be able to graph this without the use of a calculator. So let's go to the point 5 for the y-intercept, and then my slope is 1. Up 1 over 1, up 1 over 1, and I'll do that a few times. Okay, let me draw my line. And after I'm done drawing my line, this graph is g of x. We've just graphed g of x. Okay, now let's compare this to the parent function. So I'm going to graph the parent function also. I'll do the parent function in blue. Can you see how the parent function has a slope of 1? We've already talked about this earlier in the video. Slope is 1. Y-intercept is 0. Let's graph that one. 0 is my y-intercept, and up 1 over 1, up 1 over 1, up 1 over 1. Okay, so here's my graph of the parent function. And this is f of x. This is the parent function. And I should probably label those two. This is f of x, and this is g of x. Now, they say to compare. There's two things that I should be comparing when I write my sentences. And I just wrote those two things down here. I want you to compare the slopes and compare the y-intercepts. Let's do that. The slope of g of x is the same as the slope of f of x. Can you see that not only in the picture, but can you see it numerically? Maybe I should highlight it with a highlighter. Can you see the slopes are the same? So that's what I should write first, and I'll do that now. And you can see I did that here. The slope of g of x is the same as the slope of f of x, so these lines are parallel. Next, let's compare the y-intercepts. The y-intercept of g of x I'm going to highlight up here. It's 5. You can see that in two places, both on the graph and in the equation, while the slope of the y-intercept of f of x is 0. So now I want to just say that g of x this line has just been translated 5 units up on the y-axis, or I could just say the y-intercept of g of x is 5, while the y-intercept of f of x is 0. So I'll do that next. And so you can see I just wrote that. So this would be graphing. I got that taken care of here, but when I compare the two, that would be me writing a statement comparing the slope and comparing the y-intercept. Let's quickly do one more just for another example. Let's go to number 29. Question 29, they want me to graph r of x equals 4x. So let's write that down. R of x equals 4x. And then they want me to compare this to the parent function. So r of x equals 4x, and then we got to compare that to the parent function. So as you can see, the slope of this is 4, and the y-intercept is 0. So I'll start. Here's my y-intercept. The slope is 4. That means up 4 over 1. Remember, when I say slope 4, that means 4 over 1. That means I'm going to rise 4 and run 1, which I just did. Let me do that again. Rise 4, run 1. Maybe I'll do it one more time. And I'll take out my ruler, and I'll draw a line through this. And there is r of x. Let me draw this line in black, though. There's my line, r of x. So there's the function r of x. Okay, now let me graph my parent function. And remember, the parent function is f of x equals x. So now the parent function has a slope of 1 and a y-intercept of 0. So let's graph this one. Here's the y-intercept, and up 1 over 1. The parent function is always the same. The y-intercept is 0, and the slope is 1. Let's draw that line. So I'm going to take my ruler out, and I'm going to draw that line. I'll do that in blue. And let me label this then f of x. Okay, now they want me to compare the two. So there's two things I should compare in my sentence. I ought to compare the slope, and I ought to compare the y-intercept. So let's compare the slopes first. R of x, now we use a term here, R of x, they say is stretched. The slope is 4 times greater. Can you see if I take 1 and multiply it by 4, I am stretching my graph. So the book will use the term stretch for this. You could write that r of x is stretched in comparison to f of x, but I would just say we can write r of x has a slope of 4, while f of x has a slope of 1. So I'll start with, I put that. The book uses the term stretch, so I would want you to understand stretch means that the slope is a greater amount, which it is here, 4 to 1. Now here's the next thing. Let's compare the y-intercepts. Both graphs pass through the origin. So neither graph is translated, neither graph is slid up or down the graph. So I'm just going to write that. Both graphs, and both graphs have a y-intercept of 0, okay? So you're definitely going to be asked to graph the function and compare it to the parent function in questions number 23 through 34 of the book work. And this is definitely an I can list thing. This is absolutely on the chapter test. We have to be able to graph a function, compare it to the parent function using words, okay, like I have here. Okay, one last thing, and I'm going to stop the video. A great summary of what I just went through in the last two sample problems is here. Okay? If you are comparing a graph like this to the parent function, do you notice how the slope of this graph is 1? And the parent function has a slope of 1. Whenever you have this situation compared to the parent function, you're always going to have the same slope. Now think about that. What does same slope mean? I hope you're thinking it means parallel lines, okay? So you're always going to have parallel lines in that case, but you'd have different y-intercepts, okay? Now here's scenario number 2 that could pop up. Take my highlighter, pick a different color. You could be comparing something like this to the parent function. Now you notice here, you have a different slope, but the y-intercepts are both 0. In that case, you'll have two lines crossing through the origin, but you'll notice they'll be at different angles. They'll have different slopes, but the same y-intercept. And here's those terms. When the graph is steeper, we use the word stretch for that. But if you have a graph that actually has a lower slope than the parent function, there's a term for that. It's shrink. And then there's one other thing. You could have a situation like this where m's a negative amount and the graph is actually going downhill where the parent function goes uphill. When you have a graph that has a negative slope, that's called a reflection. So stretch, shrink, and reflection are 3 terms that you should definitely know. I'm going to pause the video here. If you have questions, make sure you ask in class.